Okay, it's time to address this. I have been dabbling with Electric Universe stuff a bit, and I've been receiving lots of angry comments. Unsurprisingly, many of the comments end up talking about how the SAFIRE project proves the established theory wrong and the electric/plasma universe nonsense right. Of course, a YouTube giant such as myself should really give a shout out to the smaller channels. So at this point, it is only fair that I highlight a video from a small channel called Professor Dave Explains, and he talks about SAFIRE. The link is in the description. Dave took a different approach by looking at the organization and the general principles behind what they are saying. I am going to look at what they say is evidence for their claims. For those who aren't in the know, the SAFIRE TM project claims that they can reproduce the conditions on the surface of the sun and thereby validate the electric sun model, ignoring the fact that the electric sun idea can already be disproven using observations from well before the whole SAFIRE team started. In addition, they claim that they can generate clean energy, heating, nuclear waste management with their plasma reactor. I would like to highlight that they have actually published one paper in a peer-reviewed journal. Unfortunately, the paper is really quite uninteresting and completely unrelated to the electric sun nonsense. They had another paper in preparation, but that has never materialized, as the only physicist on their team realized that they were actually intending to do a lot of crackpot physics, and he left. No one else in the team has the skill set to address the reviewers' comments. For the whole thing around the organization, history, and questionable practices, again, take a look at Professor Dave's video. I will just focus on some of their claims. One of the more outrageous claims that the SAFIRE team makes is that the process can use radioactive elements as fuel and that the process can induce nuclear transmutation, thus rendering the radioactive elements benign. And this is where it gets interesting. Before we get into the nitty-gritty of the results page, we must first consider their methodology. SAFIRE uses an approach called design of experiments, which in my opinion is a terrible name for a methodology as it's just confusing. DOE is a method where rather than manipulating one variable, you manipulate lots of variables and try to tease them apart in the analysis. And this is a very powerful approach when done right and has many applications in business, economics, agriculture, and even biology. But you have to make sure that you are doing it correctly. And the first step in making sure that you are doing it right is by asking, are you doing physics? If your answer is yes, then you're not doing it right. The bottom line is that however powerful and sophisticated a DOE design is, it is just not good enough for physics. The SAFIRE team argue that this approach is chosen due to the fact that it produces fast results, and I can't argue against that. It does bring results very quickly, but they're crap results. The issue is that if you take a single independent variable and test that, then you have a simple relationship. Let's just take the simplest that we can formulate and say that the dependent variable is linearly proportional to the independent variable. Nice and easy to test. You just change your IV and measure your DV. Now, if you are strapped for time and have multiple variables to test, you can introduce a second independent variable, and let's just assume that the relationship between your DV and IV is also a simple linear proportionality. And this will work, and it is pretty straightforward, provided that there is no relationship between your first IV and the second IV, or in other words, they are orthogonal. That means that changing your first IV does not change the second IV, and as long as you manipulate the variables in a systematic way, you can rapidly generate a lot of data. But what if they're not orthogonal? Well, then you have to characterize the relationships between IVs, and that gets messy. There's also the additional problem of uncertainty. The uncertainty in the measurement of one IV will propagate to all other IVs, and you'll end up with each IV being poorly defined. Of course, you can do a series of tests to accurately define each interaction between the different variables, but that takes a long time, and you end up having to do a lot of, well, classic lab-based controlled experiments, and you have eliminated all the advantages that the design of experiments approach brings. So, with design of experiments, you are left with essentially statistical methods and poorly defined variables. In other words, it's an observational approach, not an experimental approach. Your approach may work for softer sciences where it is unreasonable to demand precise control over each factor or very tightly controlled experiments, but in physics, it just isn't good enough. So let's dive into those results. And I'm just going off the experimental results page on the Orion website. Now, Orion, by the way, is the company that they have set up to sell their products, and they're currently trying to get investors on board. If you are looking to invest, it may be worth having a chat with a physicist about this. Actually, don't bother. They will just laugh at you and take the investment prospectus to the nearest bathroom so they don't have to use comparatively valuable toilet paper. Seriously, don't bother. And we start with these images. And these are what are called EDX maps. And they're rather fun. The claim is that these images show that transmutation happened in the process of their experiment because these elements were not there before the experiment. And sure, to the untrained eye, why not? After all, the guys with all the gear tell you that this is the case, and they're apparently being quite transparent by showing you the results. So it must be what they say it is. But that is the untrained eye. And for this, we must talk to someone who understands the method and is experienced with EDX. I just so happen to know a guy who has 2 thumbs and does this sort of thing on a regular basis. Do I need to do the gesture? EDX stands for Energy Dispersive X-rays, and it is a useful analysis tool for figuring out the elemental composition of your sample. The maps are commonly created using the electron source in a scanning electron microscope, which fires electrons at your sample. What happens is that the fired electrons knock an electron in an atom out of its orbit, and that leaves an empty energy level. A higher energy electron in the atom can then relax down to this empty state. To do so, it needs to emit a photon with energy equal to the difference between the energy levels. So the difference in energy levels, and therefore the photon energy, is also characteristic of the element. So when taking these maps, you tune your detector to these characteristic energies and take images of your sample. And here is an example of some EDX maps performed properly. And for the purposes of this video, we will just look at the top row. In the left panel, we see an SEM image of the sample. In the second image, we see iron mapped out. Note how the object is really bright and the background is really quite dark. This is because there's a high iron content in the object that really stands out above the noise floor. When we look at the third image, we see the map for oxygen. Once again, really bright and clear, although not as clear as the iron map, but sufficient to conclude that there is indeed oxygen in there. Then we look at aluminium or silicon, and you can see the object, but you can also see that the background looks like it contains these elements. We can then get the same when we look at the map for sodium or calcium. And you can see the object because using this method, the topography of the object actually still comes through. And this is actually one of the reasons why this method can be so damn powerful if used correctly. But in reality, in these images on the right, there is buckle there. But the image still has some color, so surely that means that the elements are there, right? Well, no, that is just noise. It's just random noise. And this is the bane of every physicist's existence. I'm pretty sure that 90% of my time spent doing experiments is focusing on minimizing noise. The issue is that signal to noise ratio. Any measurement will contain random noise and actual desired signal. If there is more signal than noise, then it's good. If there's more noise than signal, then it's hard to make sense of your data. So it follows that you want lots of signal and little noise. The easiest way to demonstrate this actually is with audio. One of these is a recording of a piano with a lot of noise, and the other is just noise. Can you tell which one is which? I will reveal the answer shortly. The same goes for this measurement of a magnetic hysteresis loop. We start with a lot of noise, but we then reduce the noise through some clever techniques, and the information inside the noise becomes more discernible. But at the start, there may as well not have been a loop in there. So when we look at the proper maps, we take the iron map as having lots of signal above the noise floor, the oxygen map as having a decent amount of signal above the noise floor, aluminium or silicon map has no signal above the noise floor, and the same for sodium or calcium. And we will put these maps at the top of the page and then pull up the results from the SAFIRE team. Here we have the SEM on the bottom right and different maps on all the other panels. They use this image to claim that their process produces calcium, cerium, lanthanum, carbon, and oxygen. And I ask you, is this convincing evidence of the presence of these elements, or is it just noise? What about this image, which they use to claim that they are producing phosphorus, silicon, titanium, oxygen, magnesium, calcium, sodium, potassium, aluminium, carbon, chlorine, and sulfur? What they are doing here is equivalent to taking this recording and concluding that there is a piano in there. Yes, that recording is the one without the piano. It's pretty obvious. The one with piano sounds completely different. Listen. No? Well, that just means that you can't work with the SAFIRE team then. But it doesn't stop there. The claims of transmutation go further. During a discharge in their experiment, they measured the optical spectrum and claimed that the spectrum shows that there is manganese in the system, even though none of the components are made of manganese. Therefore, they claim that manganese is being produced during the experimental run. They talk about these three triplets. The first triplet shows 3 spikes at 403.08 nanometers, 403.27 nanometers, and 403.31 nanometers. The second triplet shows 3 spikes at 475.4, 478.3, and 482.35 nanometers. And the third triplet shows 3 spikes at 601.35, 601.66, and 602.18. And they claim that these are characteristic of manganese. Of course, they are careful in stating that there's an art to this, but they highlight that the likelihood of this being a combination of other elements is very small. But here's the problem. I suspect that they p-hacked this result. They just cycled through the list of elements and asked the software if each peak could be characteristic of each element, and the software then came back with, yes, each of these peaks could work for manganese, if you squint. Without further investigation, you conclude that one of the elements then fits all the data, so surely it has to be the best solution. But then I come along and actually do some further investigation. Now, the second and third triplets are actually a good fit for manganese. The big giveaway is the first triplet, however. Manganese has a peak at 403.076 nanometers, which fits the first one, given that the uncertainty in the published values for manganese is 0.01 nanometers, and the uncertainty in the measurement is 0.1 nanometers. Now, I don't know the exact uncertainty in the measurement, but I'm being quite generous here to help them out. Manganese also has a peak at 403.307 nanometers, which could fit that third peak. But now we have the 403.449 nanometer peak, which doesn't fit anything, but the software told us to squint. And we can say that the peak at 403.307 nanometers actually fits the second peak almost as well as the third. So we can say that this is actually the peak that we detected. As long as we aren't too concerned about detail, we can then say that the 403.449 peak of magnesium fits the final peak in the triplets. But it's still outside of the uncertainty. The software will allow you to do this, but that is because the software is dumb. It doesn't understand what it's looking at, and it doesn't know what you are doing. It's just a dumb bit of code. The SAFIRE team claim that the manganese is the best explanation because it is a single element, and surely that is then the most likely explanation. But there is another one. Iron has peaks which match lines 1, 2, 3, 4, 6, and 9 without the jiggery-pokery. Carbon has peaks which match lines 5, 7, and 8, again without any jiggery-pokery. What else do we know? Well, we know that many components in the chamber just so happen to be made of a steel alloy, which contains lots of iron and a dash of carbon. So what is more likely? That the chamber contains manganese, which we know not to be present before the experimental run and doesn't actually fit the data that well, or that the chamber contains iron and carbon, which we know to be present and does fit the data very well. That being said, I do not have the actual data despite me asking for it, so I can't perform the analysis properly myself. I'm just highlighting what all of this looks like to me. This is the danger of p-hacking, and it demonstrates the importance of a hypothesis-driven approach. The team was really hoping to discover transmutation of elements without a proper hypothesis saying which elements they could expect. And therefore, they just tested all of them and shouted Eureka when they found something that they thought would match. The issue is that spectroscopy software just takes your measured spectrum and consults a database containing the reference values for the peaks of each element. In essence, you are correlating your measured spectrum with 92 elements and actually any combination of these elements to see which one matches best. In essence, you aren't testing how two very specific variables correlate. You are testing how one variable correlates to any arbitrary other variable. And this kind of approach will leave you with the conclusion that Nicolas Cage's acting makes people want to drown in a pool. As a scientist, it is important that you do everything to try to prove yourself wrong. You have to think of every other explanation that could give you a result. And this is especially important if the result appears to confirm your hypothesis, as your own biases will run haywire. If you fail to do that, you get struck down during peer review, or even worse, it goes unnoticed during peer review, and it is the community that points out that you have made a rather trivial error. And that's just embarrassing. So, with that knowledge, I ask you, did SAFIRE really show transmutation? Or did they fuck up because they don't understand what they are doing? You decide. I am pretty sure what the data shows, but I'm happy to be wrong. And with that, I would like to thank all my patrons who know who they are and how awesome they are. Their names will pop up on the screen shortly. I have also set up a Kafefi page if you would like to impart a one-off donation to support this channel. I thank you very much in advance, but thank you all for watching, and you'll see me next time.